Okay, so I just had 4 minutes of talking to myself. So I was going, can anybody hear me? Yes. So people I see have checked in. So my apologies. I'm feel like I'm having technical difficulties. I've got my camera on. Can anybody see me? Everybody see me now? Yes, and you can hear me, obviously. So good. I wanted to point out that from my circulatory students, they informed me that Mindy was on the camera, and I'm on the camera, and I know Denise will be teaching on Sunday, and I'm going to talk to her, but no promises that she's going to be on camera. She's not. She's kind of camera shy, if you know what I mean. So don't get used to it completely. Anyway. All right. As I was saying, we're going to be doing, well, as I was saying when you couldn't hear me, we're going to be doing structure first tonight, and then we're going to, we're going to be doing review, because I've not only got review for the integumentary system, but I've also got review for a little bit of structure. So you're kind of going to have a little bit of review. Mindy was on camera just for a little bit. Oh, okay. I heard she was on for the whole class, so maybe I misunderstood. Anyway, doesn't really matter. So yeah, like I say, I doubt that Denise will be on camera even. Well, she might just show you what she looks like, but no guarantees of that either. All right. Let's see. Usually, let's scroll down. We're going to start. So go ahead and get your structure worksheet out, your blue book, okay, this book here, or green book, whatever you have, and we'll get started. If we have errors in our homework, how are we notified? I'm not going to grade your homework as far as errors. Hopefully you had it done before class. You can fix it by going over the material as the instructor goes over it in class. So sorry, I'm just checking to make sure you did it. That's the key. That's the important thing. So you're somewhat familiar about it. Okay. Everybody, I hopefully can see the screen. And focus on structure. We're going to start with the hamstrings tonight. All right. Oh, shoot. Oh, there it is. I'm signing into visible body so I can show the hamstrings also. Which page? So notice on the lower left-hand corner, it tells you the page usually. It says 102 and 103. So just to make sure, I'll go there. Very few times it isn't correct. I know that sometimes it refers to the blue book and the green book don't match up, but I usually have notes for that when that happens. So anyway, okay. So the hamstrings, you've got the first three in the on your structure worksheet. Is everybody where they need to be, having the structure worksheet out and ready to fill in the origins, insertions, and actions? Yes, good. Okay. And no. Oh, uh-oh. Okay, so Carlos, are you going there, or do you have any questions? Are you not sure where you need to be? Got it. I'm looking for the paper. Oh, I have my paper all filled out, so I don't want to. Yeah, the structure worksheet in the packet, whatever page number that is, that says structure worksheet up at the top. It's the second page of the structure worksheet. We already went through it. Page 48. Thank you, Ashley. So hopefully you find that. All right. So notice for the hamstrings, biceps femoris is for the B, semitendinosus is for the T, and semimembranosus for the M, BTM. All right. Oops. Sorry. Okay. So why does it say BTM? Anybody want to venture a guess? If you're in my circulatory class, or if you had been in my circulatory class, you should know this. And to go over it. Anybody? No? TM stand for? It goes up to the bottom is the answer. Yeah, thank you, Crystal. It goes to the bottom. All right, they all come and attach to the sit bone or the ischial tuberosity. Okay, so it stands for bottom, and that's lateral to medial, BTM. Medial is the most medial. I mean, semimembranous is the most medial. Biceps femoris is the most lateral. All right. So let's go ahead and go to the biceps femoris. All right. So biceps being two heads, it's got coming up here and attaching to two different places. All right. Or the origin. So that's the difference. I'm lost. We was in the bathroom. Sorry to hear that, Azalea. So we're going over structure. We're on page 102 on our book, and we have our structure worksheet out. We're about to go over origins and actions. Hopefully that hopefully that answers the question. So sorry. Give me 1 second. Okay. I had a little thing I had to do. All right. Okay. All right. I'm lost. I'm not sure where to find this worksheet. The worksheet is in your packet, Nicole, in your 100-page packet, page. Oh, now I'm sorry. 40 something. Were you here on the first day? 48. Thank you, Eric. I deleted Ashley's. Page 48 in your homework packet. Okay. Okay. Page 38 wasn't it? Haha. Yeah. Okay. So hopefully you're there. All right. Origins and insertions. All right. The origin is the ischial tuberosity and also of the ischium. Okay. So that's the, oops, sorry. That's the origin. All right. Is the ischial tuberosity of the ischium. I don't know if there's an ischial tuberosity anyplace else. I think that's pretty much the only origin is the on the ischium. That's kind of a joke. Anyway, the insertion is the head of the fibula, and no, I should get my drawing tool out and illustrate that. Hi, Alexis. Okay, the head, and I thought I had my drawing tool, and I'm sorry. Technical difficulties. So the head of the fibula here, and the lateral condyle of the tibia right here. Okay, head of fibula, lateral condyle of tibia, coming up to the ischial tuberosity. Like I say, for all the hamstrings, they all come up to the ischial tuberosity of the ischium. All right. Now the action of biceps femoris, if I get out the tool pointer, oops, I'm sorry, it'll have the actions together, I guess. So we're just going over insertions. Can you repeat, please repeat one more time, origin? Yes, origin is the ischial tuberosity. Okay. Yeah, we haven't gone over that in circulatory yet. Actually, we're going to go over it tomorrow night. So this is good timing. All right. So it's coming up to, well, we went over ischial tuberosity last time. But anyway, ischial tuberosity, that's your sit bone. Okay. The head of the fibula and lateral condyle of the are the insertions. All right. So O is an origin, I is insertion here on the page. All right. So going down, semitendinosus. Oops, clear my scribbling. Origin and insertion are, once again, ischial tuberosity of the ischium. It's going to be true for all three of them. And now, oh, now this is the medial proximal tibia. Okay. Head of the fibula. So it's coming down here. Oh, maybe I was pointing this to the wrong, the action. Oh, we haven't done, David, we haven't done the actions yet. We're just doing origins and insertions for all three, and then we'll do actions. Okay, sorry. Next, everybody good for semitendinosus, origin and insertion? Good, yes. All right. Thank you. And last but not least, semimembranosus. You can see this is once again the most medial of the three hamstrings. Okay. And this is origin is ischial tuberosity of the ischium as promised, as well as the medial proximal. So basically the origin and insertion the same for semitendinosus and semimembranosus. Okay. Draw, please. So, all right, medial proximal tibia, all right, to the ischial tuberosity. So you can see the is the ischial tuberosity for all three muscles. Once again, going up to the BTM. All right, coming down for the semimembranosus, the medial proximal tibia. Okay, which is down here. From here all the way down to here. All right. So what I want you to do, well, let's do the actions, and then I'll do this little exercise. It's kind of fun to illustrate where the hamstrings. You can actually feel the tendons of the hamstrings. We'll do that. But let me get the actions out of the way. So the actions for all three of them, it's extension of the femur and flexion of the knee. Okay, they all extend the femur and they all flex the knee. All right. Now, you can see here that biceps femoris comes out to the lateral side, okay, whereas both bicep semimembranosus and semitendinosus come to the medial side, okay? So that's the different action, medial rotation of flexed knee for semitendinosus, semimembranosus, and lateral rotation of flexed knee. So what does that mean? If you're sitting in a chair, you have a flexed knee. As your knee is flexed, you can actually laterally rotate and medially rotate, and you're using different muscles to do it. Okay, when you medially rotate, you're using the semitendinosus, semimembranosus, or semitendinosus, membranosus, and when you laterally rotate, it's lateral rotation of flexed knee. It's biceps femoris. Okay. So let me change the tool again. So what I want you to do, hopefully you're sitting in a chair and your knees are bent, okay? Your right foot is turned out. Put your right fingers beneath the outer right thigh and the feet of and you'll feel the biceps femoris, the tendon of the biceps femoris. Feel that ropey part. I'm reaching down and grabbing my tendon of the biceps femoris, right behind the right side of the back of the knee. Anybody feel that? Okay. Now put your left hand on the inner lower thigh and turn your foot inwards, and you're now medially rotating. And the more superficial tendon is semitendinosus, and the deeper one is semimembranosus. Okay. So if you kind of what I'm doing is I'm dorsiflexing my foot, and I can really feel them pop out into my hand. Okay. Hopefully you can feel that. Isn't that cool? Those are the tendons. So laterally rotate your foot out. That's biceps femoris on the outside, on the lateral side. Medially rotated, and it's biceps femoris. Semitendinosus, semimembranosus. Okay. I like that little exercise. All right. And the biceps femoris is the only muscle that laterally rotates the bent knee. That's the only one. Semitendinosus, semimembranosus. I don't know if they have help, but at least there's two muscles there that do that. All right. So yeah, the cool thing about these tendons, they can be harvested for reconstruction of the anterior cruciate ligament. When there's, you hear people having an ACL problem, which is anterior cruciate ligament. They can actually harvest these tendons to help replace that ligament. So that's kind of cool too. All right. Anything else I want to share about that? Nope, that's it. Okay, let's see if we can bring up the, oh, no, it's gonna, you know what? I'm gonna show the video for the hamstrings while I try to bring up muscle premium, see if I can do that. So hold on. Here we go.
The hamstrings are located along the posterior thigh between the vastus lateralis and the adductor magnus. As a group, the hamstrings and their tendons are easily palpable. Biceps femoris is the lateral hamstring. It has two heads, a superficial long head and a deeper, indiscernible short head. The medial hamstrings include the two semi-muscles, the semitendinosus, which lies superficial to the wider and deeper semimembranosus.
So the hamstrings. They get their name from 18th century butchers who used to hang hog carcasses in their window from the hamstring tendons. Doesn't really have a lot to do with what we're talking about here, but it's still kind of interesting. So let's palpate the hamstrings. My partner's prone on the table, and I'm going to begin by asking my partner to just bring his foot toward his hip, so he's flexing the knee. Go ahead and give me a little resistance there. There you go. And there we can see a great example of the hamstrings. We've got the semitendinosus belly here, the semimembranosus deep to it, and here's that biceps femoris laterally, and there's that tendon coming around to the head of the fibula. Great, and relax. So let's take a moment to notice that the hamstrings really only fill up that central portion of the posterior thigh, unlike the quadriceps. It's really quite a small region right here. And if I ask my partner to go ahead and contract again a little more, there we have a visible line that separates the biceps femoris from the vastus lateralis. And there we have the line between the semi-hamstrings and the adductors over here. Good. So let's isolate the one bony landmark at the base of the pelvis where all the hamstrings attach. Here, just past the gluteal fold, is the ischial tuberosity right there. And if you've ever sat through a long concert on a hard chair, you know where your ischial tuberosity is. And that's the attachment for the hamstrings. So I'm going to ask my partner to just raise his foot up a little. And wow, right there, I feel the broad, strong tendon of all the hamstrings. Good, and relax. And from there, I can work my fingers down and feel here on the lateral side the biceps femoris belly. There, as it becomes tendinous here on the lateral side of the knee. And then I can go back to the ischial tuberosity and follow the pathway of the semitendinosus and membranosus. Tendinosus sits on top, and there all the way down to the medial side of the knee. Go ahead and just hold your foot up right there. There we go. There's that semitendinosus tendon. And then deep to it inside a little bit is the semimembranosus. And then there was that biceps femoris tendon here. So finally, we can shorten the hamstrings by flexing the knee and even extending the hip a little bit. And we can lengthen the hamstrings by extending the knee. And if my partner were supine, I could even flex the hip.
All right. So that was the video for the hamstrings. And let me see if I can change the screen. Where am I? Yeah, there we go. I brought up the hamstrings just to kind of show you the semimembranosus and semitendinosus. Once again, all three of them coming to the ischial tuberosity. They're not in the exact same place, but the medial proximal tibia kind of gives you an idea. All right. And then the biceps femoris, once again, let's see if I can move this up. Oh, there we go. Biceps femoris. So there's one head and the other head. So I'm going to take this bigger one that's coming up to the ischial tuberosity and coming to the head of the fibula and fade that one just to show you the other biceps femoris, like I say, two heads. And that shows you both of the biceps femoris, okay? And you can see where this would laterally rotate, whereas these two, but a semitendinosus would medially rotate, okay? Kind of cool. All right, good. We'll see if I can bring up the other ones as they happen. All right. That is it for the hamstrings. What's the next muscle we are going to? Gastrocnemius. Everybody got all the actions for the hamstrings? Yes. I'm getting a bunch of yeses. If you need me to go back, no problem. Okay. Okay, if you need me to go back, I will. All right, just let me know. Okay, gastrocnemius. Two heads. Okay, this is the largest muscle below the knee. It can play a big part in plantar fasciitis. I don't know if anybody has had issues with that. I have, and it really helps to kind of stretch it out also. So stretching is a good thing. All right. Once again, two heads for gastrocnemius coming down to the Achilles tendon. All right. For the origin insertion, medial and lateral epicondyles of the femur. So, okay, these are the, I forgot to change this. Oh, shoot, sorry. Oh, I'm so sorry. I forgot I didn't switch. So yeah, I was talking like you were seeing this. This is let me go back to. So I am so sorry. Forget to switch screens. So there's gastrocnemius, two heads. Once again, it shows exactly what I was talking about. Two medial head and the lateral head, and then the Achilles tendon coming down. So my apologies. Once again, here's the origin insertion, medial and lateral epicondyles of the femur. So that this is the femur right here, okay? These are the condyles. Bumps right here are the condyles. Epicondyle means, epi means above. So above the condyles are these two epicondyles. Okay, so right here and here. Consequently, right and right there. Okay, coming down to the calcaneal tendon to the calcaneus. Calcaneus being right here. Okay, it's called calcaneal tendon. To me, it will always be known as the Achilles tendon. I think they tried to change it to the calcaneal tendon. So that's what we're going to refer to it as because that's what it says here, but it'll always be the Achilles tendon to me. All right. Does anybody need more time with this? Yes. But what are you drinking? I'm drinking tea It's called peace tea. It's peachy, peach flavored tea. So yeah, it's just something to get my throat wet so I don't lose my voice talking so much. I'm not used to talking so much. Well, I do in circulatory class, but that's it. Yeah, it is. It's pretty tasty. All right. Let me know if you need more time. Coffee, I can't drink coffee past 6 o'clock at night. I wouldn't get any sleep. Yeah. But I guess maybe decaf. I don't know. Anyway, everybody good? The action for gastrocnemius, if I change my tool back to the pointer rather than the pen, is plantar flexion of the ankle. Okay. It also assists in flexion of the knee. Why does it assist in flexion of the knee? Because it crosses this joint. Okay. So it comes up and crosses the knee joint. That's why. And then also plantar flex. So it brings the back foot up, so you're plantar flexing the ankle. All right. Hopefully you have that now. It's all filled in your chart. So gastrocnemius is the muscle. This is on page 110 in your book also, by the way. On page 111 is soleus. So gastrocnemius and soleus have a special relationship. They work together really well. So the next muscle we're going to go to is soleus. Okay, you can see they tragically cut away gastrocnemius here to show the muscle right underneath or deep to gastrocnemius, cut and reflected. I don't like to have my muscles reflected, but you know, whatever. Anyway, this shows a really good point to it. So this, I'm sure it'll tell you about it, but the gastrocnemius and soleus share this Achilles tendon. See here, it's actually called Achilles tendon instead of the whatever it was written there, calcaneal tendon, I guess. All right. So on page 111, it shows it also. The origin is soleal line of the tibia and the head of the fibula. Okay. Head of the fibula right here, and then that soleal line. Now you know why we went over all these bony landmarks. Remember the soleal line of the tibia? You can go back and look at it if you don't. But same insertion as gastrocnemius, the calcaneal tendon or the Achilles tendon to calcaneus. Soleus is, by the way, Latin for flat sort of sandal shape, like a solefish, I guess. Anyway, all right. the actions, or the action, I should say, of soleus is just plantar flexion of the ankle. Notice it is not the flexion of the knee, and hopefully that's obvious why it's not, because it does not come up like gastrocnemius and come up to the femur to help flex that knee. Okay, it's just on the tibia and fibula coming down the heel tendon. All right, so it really, it's a very powerful muscle. It pulls against the force of gravity to keep the body upright by stopping the body from falling forward. All right, it holds it upright. It's in that way, it's stronger than gastrocnemius in this action, because that's all its job is. It just plantar flexes the ankle. Okay, so everybody good? Right, good. Yes. Yeah, you good. All right, I'm going to show you the video of gastrocnemius and soleus. By the way, people say they have problems with their volume. Try and adjust your volume. I have my volume up. There's nothing more I can change as far as volume goes. And I apologize if your volume isn't working. Okay, so here we go.
The large muscle mass of the posterior leg is composed of the gastrocnemius and the soleus muscles. Together, they form what is known as the triceps surae that attaches to the strong calcaneal or Achilles tendon. The superficial gastrocnemius has two heads and crosses two joints, the knee and ankle. The soleus is deep to the gastrocnemius, yet its medial and lateral fibers bulge out from the sides of the leg and extend further distal than the gastroc heads.
So, before we go to the table and palpate, let's just see these muscles in action. I'm going to ask my partner to just stand up on his toes, and as he plantar flexes the ankle, wow, what a great example of the gastroc and soleus. Here we have that lateral head of the gastrocnemius. There's the medial head there. Here we see a bit of the soleus bulging out the sides and coming out underneath as it blends in with that calcaneal tendon here at the calcaneus. And now let's turn them around. Go ahead and face the other direction and stand up on your toes. And notice that the gastroc and soleus are visible from an anterior view as well. Here's that edge of the shaft of the tibia, and all of this tissue right here is the soleus as it bulges out the side. We can even see a bit of the gastroc head here and here coming out the side as well. And so all of that is part of the muscle tissue that we'll be accessing on the table. So let's go do that. So my partner's prone on the table, and we'll begin by isolating the gastrocnemius. I'm going to just set my hand on my partner's foot and ask him to just try to step on the gas a little bit. Great. And as he plantar flexes, there again we can see those gastrocnemius heads right here. And if you ever get lost and you can't figure out exactly how long or short they are, you can pretty much divide the leg in half, and right at that half point will be the bottom of the gastrocnemius heads. And if I want to get my fingers on them, I can just really grasp some of this superficial tissue of the calf. Now notice, I'm not grasping all of this. No, that's the gastroc and the soleus. No, we're just looking for the gastrocnemius here. And I can follow the bellies up to the back of the knee. And if I ask my partner, just try to bring your heel toward your hip. That's right. So as he tries to flex the knee, there we can see the hamstring tendons. And that's where the gastroc heads pass in between those tendons to disappear into the back of the knee where they attach onto the condyles of the femur. Now those are the gastrocnemius heads, and deep to those will be the soleus. And really, if you grasp the tissue of the calf, that deeper, really massive amount of tissue will be the soleus. Yes, the three flexors are deep to the soleus, but they're really quite small. This will be the soleus. And I can follow it distally as it blends into that calcaneal or Achilles tendon to attach there at the calcaneus. Good. Now, a fun little way that you can differentiate the gastroc from the soleus is you can flex the knee and ask your partner to step on the gas. Now, since the gastrocnemius is an ineffectual plantar flexor, in this position, it doesn't really engage. It's nice and flaccid. But deep to it, all of this tissue that is engaging is all the soleus. So it's a fun way to sort of turn off the gastrocnemius. Great, and relax. And finally, if we want to shorten the gastrocnemius, I can flex the knee and plantar flex the ankle. Plantar flexing the ankle also shortens the soleus. And to lengthen the gastrocnemius, I can extend the knee and even just dorsiflex the ankle. And dorsiflexing the ankle will also lengthen the soleus.
So I kind of the muscle premium and to show you the knee flexion, okay, and it gastrocnemius as well as the hamstrings for that matter, okay, and you can see how the hamstrings are pulling up to flex the knee, and gastrocnemius is kind of pulling from the bottom. So this is a good little illustration, but notice underneath, all you have is, well, you have another muscle here, I believe, popliteus, excuse me, but we'll go over that another time. But you just have gastrocnemius. You don't have soleus underneath doing the flexion once again because it's just attached to the below the knee. Okay, exit that, and we'll go to flexion as an action. See what, oh my goodness, look at all the muscles. But really what let me see if I can. This, well, all we're concerned about, there's the soleus and genius. So these two muscles are plantar flexing the ankle. Notice bringing that right there at calcaneus, bringing that up. Okay, kind of a cool little illustration. Hopefully you get an idea from it, right? All right. Everybody doing okay? Yeah, that's a good answer. All right, let me exit that and we'll go back to our wonderful, remember to go back to the slide that I'm talking about rather than something else. All right, tensor fascia latae, the next muscle on our list. What do they do with my, 1 second. I just want to make sure I'm getting all of the, I was just looking at the syllabus, make sure I'm going in order. All right, so we're at tensor fascia latae. This is this muscle right here. The most anterior muscle of the front of the hip, okay? Most lateral muscle on the hip. This muscle is really good for runners and cyclists. It actually means fascia means stretcher of the wide band. Okay, tensor fascia lata. All right. Okay. So before we get started, oh no, let's do it after. I think it works good once you know the origin and insertion in action. I'll have a little exercise just like I had for the hamstrings. Okay, don't let me forget. The page 100 in your book, by the way. Yeah, this is the last page on last one on this work page for the worksheet. Okay, origin and insertion, the iliac crest. Okay, posterior to anterior superior iliac spine. Okay, right behind the adduct, in other words. Okay, now coming down to the iliotibial tract to the tibia. So that's why it seems like, I'm just going to go back real quick. I know you're writing this down. I'm hoping you're writing this down anyway. Seems like such a short little muscle here, but the way they describe it's kind of that iliotibial tract coming down makes that extension that much longer from all the way from here down to here. Okay, it's really just like right here once it gets down to the iliotibial tract, if that makes sense. Okay. All right. Oh boy. All right. I'm gonna hope that everybody has that information and move on to the. If you need more time, let me know. Actions. It only assists. It assists in abduction of the femur. It also assists in medial rotation and flexion of the femur, as well as extension of the knee, because it comes all the way down to via the iliotibial tract to the knee. Okay, it stabilization of the extended knee. See the little asterisk there? That's kind of a you need to know this. Get it knee? No, but really it'll be on the midterm in. I'll review it and I'll let you know more about it. But know that the tensor fascia lata stabilizes the extended knee. You might want to put that in your special notes. It's not highlighted, but I'm just saying. So when I ask you, you'll know. Okay. Down there, so. All right. Like I say, let's write down. Hopefully you have it. I am going to show the video. I'll come back to this slide. Right? Oh, wait. Okay, let me know, Carlos, when you have it. Exercise? Okay. I'm not sure what you're asking, Cynthia. Okay. No, the video is what I'm going to show. right now for tensor fascia latae. It's like 3 minutes. So, oh, I'll show you the exercise after the video. Thank you.
The tensor fascia latae, or TFL, is a small superficial muscle located on the lateral side of the upper thigh. Approximately 3 fingers wide, the TFL is easily accessible between the upper fibers of the rectus femoris and the gluteus medius.
So chances are, if you've ever gotten in an automobile, you're familiar with your TFL because it involves flexion, medial rotation, and abduction of the hip. Don't I look ready to just jump into my Maserati, huh? Well, let's see if we can access a little bit of the TFL now. So I'm going to first find the ASIS. It's that prominent bony landmark right on the top of the hip, right there. And then I'm going to just walk my fingers back along the iliac crest a little bit right here. And that little 2-inch region right there is sort of that top edge of where the TFL is going to be. And then I can pretty much run down the side of the thigh like so, and there we can see where that TFL is located. Good. And if I want to see this muscle engaged, I'm going to ask my partner to just try to medially rotate her hip against my resistance. So go ahead and try to medially rotate. Great. And if I set my hand right along that pathway, wow, sure enough, there's a very solid tubular muscle right there. I can even get my fingers on either side of it as it descends down the thigh. It pretty much ends right around here. Great. Go ahead and relax. And then when it's relaxed, I can really roll my fingers across those fibers that run in this direction. Now, how far down does the TFL go? Well, pretty much to the level of the greater trochanter. And I can find that by just setting my hand on the side of the thigh right here. I can passively rotate the hip a little bit, and there underneath my fingers I can feel the bony prominence of the greater trochanter. So this is going to be our TFL, our tensor fascia latae muscle. Well, at that point it blends into the iliotibial tract. So let's explore that for a moment. The iliotibial tract comes from here at the gluteal fascia, blends and sort of funnels and converges fascially as it descends down the lateral side of the leg, finally attach here at that tibial tubercle. So if I want to just access a little of that iliotibial tract, I can just set my hand on the side of the thigh, and deep to the iliotibial tract, first of all, will be the vastus lateralis fibers, and they're going to sort of curl and run this way. But if I work very superficially, I can feel those really dense fascial tissue that runs this way. And as I get closer to the knee, these fibers bundle together. There, my fingers are on either side, and it feels, frankly, a bit like duct tape. I mean, it's like really, really tough tissue. And that's going to be that distal portion of the iliotibial tract here, superficial to that vastus lateralis muscle. So that's just a little bit of the iliotibial tract as it descends the lateral side of the leg.
All right, and here is the iliotibial tract, along with like gluteus maximus. It shows sartorius here, which we haven't gone over yet, but this is really the tensor fascia latae, also obviously going down to the iliotibial tract, or yeah, and you can see it coming down to where he was talking about, right? Showing. Now this is the for abduction. I don't know if we can go to medial rotation. Let's see if it even shows it on here. Yeah, there it is. So medial rotation. Not as many muscles here, right? But definitely TFL. Okay. All right. Let's go back to the page. Okay, exercise. Good. Thank you for reminding me, Cynthia. I'm not sure where I might have forgotten. Anyway, what I want you to do is find your as is, okay? So reach down and find your anterior superior iliac spine, okay? And then once you found that as is, just kind of thunk down on it from it, just straight down. And I want you to try and stand up, okay? Or stand up, yeah, just kind of stand up. That's the TFL engaging, okay? Really engages as you stand up, okay? You can also feel it while you're sitting. Does anybody feel it? Feel that TFL engaging? You can also, while you're sitting in that spot, and once again, finding the as is and thunk down on it, just basically raise the other leg and it kind of contracts the TFL also. Actually, I'm raising the leg that I'm on, and it really contracts that TFL also. So I guess if you medially rotate, it would really engage. Or try and abduct. I'm not getting it as much from the abduction as well when I'm sitting down. So you do feel it. Oh, I got a couple of reactions from people feeling it. Hopefully, you're able to feel the TFL. It's kind of cool to get that as far as that goes, I think. Anyway, got it. Good, nice. All right, that's the TFL. What's next? Let's see. Tibialis anterior. So now we're going to go below the knee. Well, I guess we were below the knee with gastrocnemius, weren't we? Tibialis anterior. Yeah, it's not the hip flexor. Nope. No, we'll get to the hip flexors later on with iliopsoas and whatnot. Anyway. All right. So tibialis anterior. Okay. Let's see. Does anybody have any issues with shin splints? This muscle is usually involved with shin splints. Basically, shin, tibia, what happens is if you're doing something, usually an exercise, okay, so somebody here is saying they play soccer. I have one, I play soccer. So you're constantly running, okay? And your tibialis anterior is taking some brunt from that, and it's basically tearing away from the tibia, okay? So I guess we'll find this out next week. Let's see, whenever we do bones anyway. Or, well, I guess we'll find it out when we do connective tissue. Yeah, connective tissue is the next lesson, and connective tissue surrounds bones, okay? Every bone is surrounded by connective tissue, and that's what's connected to the muscle to the bone, okay? And when you constantly tear at it, it tears away, and it can be very painful. Anyway, shin splints. I don't recommend it. Notice also here on its interior, before I go to origins and actions, how this tendon from the tibialis anterior comes down and crosses over the ankle, okay? So it actually comes in front of the foot, all right? Kind of crosses over. It's held kind of in place by this retinaculum around your feet, your ankles, and your wrists. They have this retinaculum to hold things in place anyway. I think it's kind of cool. Origins and insertions. Lateral condyle and lateral shaft of the tibia. Okay, lateral condyle and lateral shaft of the tibia is the origin. This whole thing here. All right. So you can see where it's connecting their origin. And then plantar surface of the medial cuneiform and first metatarsal. All right. So once again, out here on the lateral side, coming around to the medial side of the foot, right here, coming to underneath the foot, plantar surface, medial cuneiform, and first metatarsal. Right? Give you a little bit more time. All right, I'm going to move on. Everybody good? Waiting for somebody to say, no, wait. Okay, the actions of tibialis anterior. Okay, change my tool. Dorsiflexion of the ankle, okay, and inversion of the foot. So basically, inversion bringing, you can see how basically it's going to bring the foot up to dorsiflex and bring the foot, the big toe up, leaving this on the ground for inversion. Okay. Dorsiflexion of the ankle and inversion of the foot. All right. Good. And go ahead. So let me explain before I play the next video. This is one muscle, okay? There are many muscles, and I'm going to say extensors of the ankle and toes is the video I'm going to play. So he's going to talk about other muscles in there. So more information is good here. He definitely talks about tibialis anterior also. So just take it all in stride and get as much information as you can from it, or not, however you want to do it. All right, here we go. Extensors of the ankles and toes.
These three muscles are located on the anterior aspect of the leg between the shaft of the tibia and the peroneal muscles. The tibialis anterior is large, superficial, and the most clearly isolated of the group. It lies directly lateral to the tibial shaft. And then squeezed between the tibialis anterior and the peroneal muscles is the extensor digitorum, which is partially superficial. And the muscle belly of the extensor hallucis longus lies deep to the other two muscles and can be accessed only indirectly.
The extensors of the ankle and toes basically fill up this region right here on the anterior and lateral side of the leg. There we can see a Great example of where they all are positioned. Good. So let's begin with the tibialis anterior, which, as the name suggests, is next to the shaft of the tibia. And there we can see it alone on the front of the leg. So in order to get a sense of where it's located, I'm first going to find the shaft of the tibia. And probably the easiest thing to do is locate the medial malleolus here, and then I'm just going to slide my thumb proximally as it becomes the shaft of the tibia. That's the very superficial shin bone that runs up the entire length of the leg. And if I come back a little bit, I can sort of fall off laterally off the shaft, just like so. And there's a very palpable edge of the shaft of the tibia. And as my thumb falls laterally, I'm now in the land of the tibialis anterior, right there. There's that belly, sort of a tubular belly running like so down past the ankle. And if I ask my partner to just dorsiflex your ankle, this muscle belly really engages. You can even see the sort of topography that it forms right there on the top of the leg. And if I follow it distally, it becomes tendinous, and there we can see a really great example as the tendon passes over the top of the ankle and comes over here to attach on the medial side of the foot. Really feel that tendon right there. And there's a couple of the retinacula that pass over the tendons to hold them down and in place. Good, and relax. And so now that it's relaxed, I can even roll my thumb across that tendon like so. And that's going to be my first extensor, the tibialis anterior. Now, if this is the location of the tibialis anterior, there we see it. Here we can also see next to it the extensor digitorum longus, that equally long belly that then branches off into 4 tendons that come to the toes. Good. So what I'm going to do is I'm just going to locate the edge of that tibialis anterior. So there's the belly I'm sort of rolling over. And there's a little gap right there. And that gap is what separates the tibialis anterior from the peroneals. And if I set my thumb right into that space, there's another equally rounded belly that seems to run down the leg. And for this muscle, I'm going to just ask my partner to see if she can just extend her toes. She's going to try to pull all of her toes back a little bit. Wow. And this belly really engages. Now, go ahead and just for fun, go ahead and just kind of wiggle your toes. You're going to kind of flex them and extend them. Oh, sure. And right here, this muscle belly is definitely sort of undulating as she wiggles her toes. Great. And relax. So if I follow that down, I know that it's going to be just lateral to that tibialis anterior muscle. And go ahead and dorsiflex again. There we can see the tendon of the extensor digitorum pass, again, underneath those retinacula, and then divide into 4 tendons here on the top of the foot. And those are the tendons of the extensor digitorum longus. Great. And relax. Now, if this is my tibialis anterior, and here's my extensor digitorum, well, where's the extensor hallucis longus? Well, that's deep between the two. And an easy way to start with that muscle is to go ahead and just dorsiflex again. Great. And do you see this tendon right here? That's the tendon of the extensor hallucis longus. And it sort of penetrates right in between the tibialis anterior and the extensor digitorum. And you can see as it kind of goes right up in between those two and lays deep here underneath the 2 other extensors. Great, and relax. So we've got those 3 extensors, and finally, just one step further, just to note where they're at, here is going to be the peroneals on that lateral side of the leg. So really the extensors are framed by that shaft of the tibia and the peroneal muscles here running from that head of the fibula all the way down past around the lateral malleolus. And finally, if I wanted to shorten the extensors, I can passively dorsiflex my partner's ankle, and if I wanted to lengthen them, I can plantar flex the ankle.
So you can see he was talking about a lot of different muscles, but really, like I say, tibialis anterior was one of them. Here is a good, I kind of isolated all the other muscles that are inverting the foot, and you can see where I have tibialis anterior, kind of had it highlighted. You can see where it kind of comes around and connects to the medial side of the foot right here on the medial cuneiform. And let me go exit this. So that was, now I can go to dorsiflexion and see the same thing. And like I say, there's a bunch of muscles here. Really, what we're looking at is tibialis anterior for dorsiflexion. Same thing. It's basically just bringing the toes up to dorsiflex the foot. All right. You can see how it's held in by, once again, retinaculum. All right. In fact, he was, I don't know if you noticed, but he was talking about the digitorum and hallucis. I think he mentioned hallucis, which is on your worksheet. So I'm going to jump ahead to that. Where it says hallucis, all you need to do basically is put big toe under origin. There's no, there are muscles that go to the hallucis or the big toe, but that's all we want you to know is the hallucis is the big toe. Okay. I'll probably mention that again once we get down to it on the worksheet. All right. And okay. So let's see what's next. Do I have my pen? Nope. Got the pointer. Fibularis longus. Okay, fibularis longus and fibularis brevis. Those are the next two muscles we're going to do. You can see there's also a fibularis tertius, which basically means that I believe third muscle, which we're not going to go over tonight. All right. Anyway, fibularis longus, fibularis brevis. And also what I want to mention, I think even on the video, fibularis is the newer term. It used to be known, does anybody know this, that it used to be known as the peroneals? Okay, so you'll see references to peroneals. Did I spell that right? I think I did. Yeah, peroneals, even though the pen doesn't allow you to write very nicely. Or for me, it doesn't anyway. So fibularis used to be peroneals. I just want you to know that. Okay, so like I say, you'll see older textbooks that refer to them as peroneals. And once again, the video, I think he talks about the peroneals in place of fibularis muscles. All right. So anyway, just remember that. All right. Origin. Change the tool so I can change my page. Peroneus. Yeah, that's the but it's peroneals as far as the group of muscles, the three different muscles, or it used to be anyway. And they changed it because it was close to the perineum, which is the muscle around the anus, basically. They didn't want to get those mixed up. That could be bad. Anyway, that's what I heard. Origin of fibularis longus is head and shaft of the fibula. Okay, so all of this, the shaft as well as the head. Okay. And now It's the plantar surface of the medial cuneiform and first metatarsal. So basically, where where tibialis anterior was connected, like right here, now this muscle comes all the way underneath and comes to this side, okay, from underneath. All right. So, everybody good there? I'm going to change it to the action. Yes. Ready for good. The action, if I change my go to the pointer, is now eversion of the foot and assist in plantar flexion of the ankle. Okay, so it's kind of the opposite of tibialis anterior because it's coming on the other side, doing a different action. Eversion of foot, and it assists in plantar flexion of the ankle. Other, obviously, the gastrocnemius and soleus is another muscle that plantar flexes the ankle, probably more prominently. This one just helps it out. Okay, good. So now we're going to move on to fibularis brevis. Okay, once again, cut and reflected fibularis longus to reveal fibularis brevis right underneath. And I'd say even deep to that fibularis tertius, but not part of what we're talking about. All right. So the origin and insertion are just now the shaft of the tibia rather than the shaft in the head. Okay, just the shaft. And coming to the base of the fifth metatarsal now, okay? So it doesn't come underneath, it just comes to the side, all right, of the metatarsal, not even on the tarsals. All right, I'm going to show the video for the, and once again, it says peroneus longus and brevis. Here we go.
The slender peroneal muscles are located on the lateral side of the fibula, between the extensor digitorum and the soleus. A portion of the peroneus brevis lies deep to the peroneus longus, yet both are accessible.
So let's begin by isolating the two bony landmarks that frame out where the peroneals are on the lateral side of the leg. The first is going to be the head of the fibula, which is located here on that lateral side of the leg, just below the level of the knee. I'm just going to set my broad finger pads here, and sure enough, there's a really prominent knob right there. And if I can't find it and I'm a little confused, I can always ask my partner to just try to bring your heel toward your butt a little bit. There you go. And as she tries to flex her knee, this tendon, the tendon of the biceps femoris, one of the hamstrings, contracts, and it attaches right there at the head of the fibula. Good. Go ahead and relax. So first landmark is the head of the fibula. The other is going to be down at the other end of the leg here at the lateral malleolus, that really prominent landmark on the side of the ankle. In between these two landmarks, as we can see, will be the peroneals. There's the peroneus longus, there's the peroneus brevis, and the tendons pass behind the malleolus to attach down in the foot. And if I want to see these muscles engage, I can just ask my partner to evert her foot. So she's going to try to swing the sole of her foot out a little bit, and wow, you can even see the sort of depression that's formed as these peroneals engage right there. And so if I just set my fingers in that tissue, go ahead and relax. There I can even roll my fingers right across and over the bellies of the peroneals. Good. Just for fun, go ahead and engage again. Just try to evert. Great. And that tissue really contracts. Good. And relax. So just to differentiate for a moment, if I fall to the anterior side of where the peroneals are, I sort of can feel the belly of the extensor digitorum longus, one of the extensors, there. And then if I fall over to the posterior side of the peroneals, there's a little ditch right there. That's going to be where the soleus and the gastrocnemius are. So the peroneals fit right here just between those two sides of those muscle groups. And then if I follow these muscle bellies distally, I can roll across their tendons, and they're pretty much all tendon here, and I can follow them as they pass behind the lateral malleolus. You can even see the peroneus brevis coming and attaching here at the base of the fifth metatarsal. And finally, if I wanted to lengthen the peroneals, I'm going to just dorsiflex the ankle, and I can even invert the foot. And to shorten them, I can plantar flex and evert the foot. So to lengthen them and to shorten them. And those are your peroneals, the two muscles here on the side of the leg.
All right, and I don't know if anybody was paying attention, but I just realized I didn't show the action, the action of fibularis brevis, which is easy enough to tell because it's the same as fibularis longus. Okay, so yeah. Somebody was paying attention. They made a comment. That's good. I guess you could do little, bunny quotes because it's the same. Anyway, let me switch to. Here it's showing the action of everting the foot, bringing the foot up, the little pinky toes up. And notice I have fibularis brevis selected. Here's fibularis longus. And the guy with the Honda mentioned extensor digitorum longus right next to it, as well as, and then soleus and gastrocnemius back here, which it's not showing because it doesn't evert the foot. So let's go ahead and go to plantar flexion. Let me find plantar flexion. I know it's here. We just saw it. Plantar flexion. Duh. And you can see here, there's gastrocnemius, soleus, as well as fibularis longus and brevis. Okay, so those are the other muscles. And it does say, wow, interosseous membrane of the leg, the medial tibia. Oh, yeah, you don't need to know that. Anyway, bring it up a little bit. And you can see here, if I select the fibularis longus and go underneath, notice how it goes underneath here. And it's got these, what are these? These are the flexor, it's another tendon. So it's these kind of go deep to that, but it goes underneath. Oh, let me fade those. So when I select fibularis longus, you can see how where it comes out. It comes all the way underneath the foot to the metatarsal and medial cuneiform. Whereas, once again, fibularis brevis just comes to the fifth metatarsal there. Okay? Yeah, I will go back to action. Carlos, give me 1 second. Let me just finish up this awesome illustration here. All right. Okay, good. That is, and let me go back as requested, the action of fibularis brevis. There you go. Let me know when you have it. Oh, origin and insertion of fibularis brevis, I will. As soon as Carlos gets the action, I'll go back to origin insertion. We're almost done, by the way. We just have one more muscle to go over, and then we'll take a break. So hang in there. I know this is a lot of muscles to go over. Okay, just going to go back up real quick to origin and insertion. Let me know when you have it, Tiffany. The other Tiffany, I should say. There's two Tiffany's. So. Okay, good. All right. Sorry about that. Popliteus, the last muscle we're going to go over tonight. Is I call him the Honda guy now. I don't know if you caught where he says when he's pressing down the accelerator on his Maserati, and it said that he actually owns a Honda. So it's the Honda guy. I thought it was kind of cute. All right, the key of the knee, he calls it the key of the knee, responsible for unlocking the knee when the leg is in extended position, okay? Overstriding while running is a common way to stress the popliteus, okay? Which ones do, that's a great question, Joanna. Which ones do we actually need to know for the midterm? There'll be a day before I do the final review where I review all of the structure and let you know what you need to know for the midterm. But this is all good information and really good to know as a massage therapist to know all of this, all right? So next, the insertion of popliteus, lateral condyle of the femur, okay? So now, remember, the condyle is the bump, epicondyle above. So now we're looking at the lateral condyle, so just out to the outside. That's the origin And the insertion is this big hunking area here, posterior proximal tibial shaft, just below the tibial condyles, which is basically up here. So when we talk about connective tissue, they'll talk about the meniscus, which is basically a disc of connective tissue, kind of cushioning right here, the femur coming down, sitting on the tibia here. All right. The popliteus, if you have an injury to the popliteus, it can mimic a meniscus tear. If this gets torn, it can be very painful. So this is kind of can be very similar if you have an injury to popliteus. Anyway. Okay. The difference, it's similar. It's even it can even have basically it's chronic pain. It can be very painful, and you can get even quicking in your knee. So I don't know. I can't really describe the difference between popliteus injury and meniscus tear. I wouldn't recommend either one. Okay, if that helps. I'm sorry, I don't have any better description for you. Don't mess with either one is my recommendation. Okay, bunch of actions for popliteus. Here. Okay, lateral rotation of the femur. Okay, it unlocks the extended knee. Once again, key to the knee, unlock the knee. Okay, it initiates knee flexion, and it also assists in medial rotation of tibia when knee is flexed. So a lot of things that it does. All right, everybody good? Hopefully I gave you enough time there. Yes, I got a yes. Didn't get a no yet, so that's good. Let's say we can come back to it. I do have a video for popliteal, so here we go. I'm going to play that now.
As its name suggests, the popliteus is located in the popliteal space. This muscle has a small, short belly with diagonal fibers. And lying beneath the upper fibers of the gastrocnemius and plantaris, it is the deepest muscle of the posterior knee.
So what we're going to do to access just a portion of it is flex the knee and locate the tibial tuberosity. Tibial tuberosity is that bony landmark on the anterior leg where the quadriceps attach, and there it is right there. And what I'm going to do is just walk my fingers around that shaft of the tibia until I'm pretty much on the posterior surface, right there. And here we have that superficial soleus and gastrocnemius muscles. But my fingers are going to just slip underneath them on that posterior surface of the tibia. And that location is where you're going to find the distal tendinous attachment of the popliteus. Now, it's not like a big muscle or anything. It's not like you're going to feel a big structure. It's more or less just a portion of bone where the tendon attaches. And just to note, I'm distal to where the pes anserinus tendons come and attach here on the tibia. So those are the semitendinosus, sartorius, and gracilis. And they're passing here, and my fingers are going to come just distal right to there. And even though the popliteus is a weak flexor of the knee, it plays the vital role of unlocking the knee from a fully extended position, which is where it gets its nickname, the key which unlocks the knee.
It's such a short video. I almost forget that it's so short. Anyway, here is the medial rotation showing popliteus here, along with what is it? The hamstrings, I guess. Anyway, we've got medial rotation. Let's see, what else can we do? So medial and lateral rotation. Let's see. So let's see lateral rotation. Does it show it here? Let's see. It's not even showing that. Knee flexion. You see, that's in there. If I hide this or fade it, there's popliteus right there. So that's basically just initiate. It helps start that knee flexion. And then once again, we have gastrocnemius and the hamstrings. All right. Good. All right. I'm going to exit that and go back to here. I believe that is it. Yeah, because next we'll be going to iliopsoas next week. All right, you guys deserve a break. I'm going to give you till 8 o'clock. All right. And then we'll start our review of integumentary system. Okay, I'll see you. Let me write it down. 8 o'clock, going to break. All right. I noticed people are signing back in from break. Thank you so much. 8 o'clock. It means that I need to come back and start talking. So welcome back. So we're going to go into the review section of integumentary system. You need this slide up and clear the 8 o'clock out. And we don't need the welcome sign definitely anymore. All right. So this is the interactive review. So what I want you to do is in the question panel, as best you can, tell me what a sebaceous gland does and why does it do it. Oh, June, as I mentioned this and I said I would come back to it, but hallucis, all you have to do is put big toe. There's no origin and insertion. There are muscles that come down to the big toe, but I just want you to know hallucis means big toe. Oh, it's up. It's just a big toe. Okay, I see some answers. It's great. Yeah, not quite, Tiffany. That's the other one. Right? Let's see. Yeah. So, Nicole, same thing. This is not the sweat gland. All right. A good many of you have answered. Some of you have, but that's okay. Yeah. There you go. Okay. Somebody, a couple more people. Yeah, as interactive as you can get. That would be great. All right. The answer that I have is probably a lot more words than you typed in here, although some of you were pretty thorough with it. So I appreciate that too. The answer is, all right, it secretes oil or waxy matter, okay, and it lubricates, and when I say waterproof, it doesn't really waterproof the skin, does it? It makes hair more pliable, all right? And it also gives an antibacterial property that inhibits growth of microorganisms in the skin. So I don't know, did somebody say that at all? Oh yeah, antibacterial. I see. Yeah, we got it. Probably a couple more people. No. Oh, there. Yeah. Okay. Oh, Debbie answered twice. Okay. That's okay. All right. So that is the properties of sebum. You can see surface lubrication, prevents drying, waterproof barrier. So kind of a barrier. Prevents loss of heat and water, antimicrobial, as I said. Okay, pro-inflammatory, anti-inflammatory. Transports pheromones to surface. So very cool. Good deal. There you go, Tiffany. Good correction. Thank you. All right. So some of you said sweat. let's give you another chance. What does the sudoriferous gland secrete and why? There you go, Carolyn. Good. Very good. Nice. And just reading along, sweat, a lot of body temperature, basically regulate body temperature. Very nice. Is the way that to take the toxins and waste out of the body. I like that. Releases all the toxins, salt, and etc. for the body. I think that's good thinking. And paying attention. I wasn't there for the lecture on Sunday, and that's okay, Ruby. Thank you for letting me know. So this is basically a review of what happened on Sunday. So maybe take some notes then. That'd be awesome. Okay, very good. What I have down here is secrete sweat, water, sodium salt, and nitrogenous waste, such as urea. All right. Thermoregulation, assist in body temperature, cooling body temperature, which many of you said. Also excretion of toxins, which many of you said too. Okay, good deal. Very good. Thank you, Crystal. Okay. Next one. So this one, obviously, we talked about body temperature. Okay, but how does the skin regulate temperature? Hopefully, I wasn't there Sunday either, so but I assume Mindy hit on this, talked about it. Anybody have any? Oh, let's find out. See if anybody. I can't see the screen. Oh, that's interesting. You might want to. People can see how does the skin regulate temperature, right? Everybody can see the screen. Is that right? You might want to restart then, Tali. I just did this question on Exam Coach. Okay, so what's the answer? You can't remember. It's okay. Okay, let's see. All right, some of you are touching on it. Yeah, good job. So I'm going to get into it a little bit with the next slide. So skin regulation, regulating temperature. When it gets cold, blood moves from the skin to keep the organs protected. Okay, it comes in. All right. When it gets hot, it triggers sweat to increase the blood flow to the capillaries, which in turn increases sweating. Process cools you off as water evaporates from the skin. Okay, so you can kind of distribute itself as far as the blood moving from in and out, depending on if it gets cold or not. The most important thing your body does is basically is it keeps you alive, all right? And then worries about the rest of the stuff. Okay. Oh, good. Thank you. Great job, Charlie. Yeah, I know. The question is a little bit vague because we just talked about, that's why I talked about cooling with sweat. So anyway. All right. Anyway. Next question. How does the skin protect from bacteria or microbes? So we touched upon this a little bit. So you can answer that. And if you have anything else. I have a couple of things that I have in mind. Definitely, yeah, good. Oh, interesting. Somebody said goosebumps. All right, I'm not getting what I'm looking for here. So let's see. Oh, wait. Oh, very good, Gabby. I think, yeah, you're getting to where I was looking for. Definitely, sebum is one thing that is a protective protection from bacteria or microbes, right? But I'm looking for. I'm just going to go to it. I'm looking for also the Langerhans cells in the epidermis. All right, part of the immune system. All right. Just protecting from that. But you definitely, the sebum and sweat coming out and protecting from bacterial and microbes. All right. Hopefully that answered your question. This is epidermis covering our body. Yeah, with the Langerhans cells in it. Definitely. All right, and once again, we already kind of went over this. How does the skin protect from dehydration? What's the word I'm looking for? Sebum. Yeah. So, since we already said it, basically sebum and that semi-permeable membrane, allowing so much in or out. I'm kind of like say a review of a review. All right. So, how does the skin protect from sun radiation? Once I finish this one, McKenna, I'll go back. Okay, remind me. Very good. Some of you are getting this, definitely. Awesome. Good job, Rachel, Gabby, Ashley, Tasha, Naomi. Good, good. You're taking it. That's what I want you to do. All right. So, okay. Oh, that's the next slide, June. So what I'm looking for here is there's a couple of things. Melanocytes produce melanin, serving as your own personal sunblock. Okay. Also, the skin builds up a shield in response to the sun's increasing thickness of the stratum corneum, right? Putting up a built-in sun umbrella for your skin. So I'll let you get this, and I'm going to go back. Somebody asked me to go back one slide in just a second. All right, I'm going to go back. This one. Let me know when you have it. Okay. And everybody good here, I assume. Looking forward to the next slide. I'll put out. And what does a vitamin D mean? Oh, shoot. I will, Nicole. I'll go back. Sorry. I probably am going too fast, aren't I? For some of you. Yeah. Okay. Yeah, it's made. What sense of it? It's made. That's a good answer. Yeah. Good, Teresa. That's the right answer. This is it. So I'm going to go to a little bit more in depth of how it is, what it means, basically. What it means is the sun touch the skin, they convert that molecule to a vitamin D3, okay? Then it follows the metabolic pathway, and it kind of shows you this in the diagram through the liver and kidneys, where it's converted to calcitrol, which is what you're looking for, all right? Increases bone mineralization and maintains calcium balance in the body. Increases absorption of calcium. Yeah, and notice that basically it has two different pathways, one from dietary supplements also. I guess, you know, people that live in not so sunlit areas of sunny Southern California, that's why they add vitamin, you know, D to milk, for example. All right. Hopefully we're all good. Anybody need any more time? Yeah, email me and ask me, Samantha. Okay. Let me know when you got it. Okay. Good. I'm going to go back up one slide real quick. Somebody asked. It should be at every office, Azalea. But it's just the advanced circulatory organs, insertions, and actions. Not this stuff, though. Okay, Chantalis. Thanks for letting me know. All right. Everybody good? Everybody needed here? Somebody else. Okay. I'm going to assume it's good. Now, our first special note of the night. Are you ready? You have to get your special notes page out. Skin aids in the synthesis of vitamin D. Simple, just a special note. Skin aids in the synthesis of vitamin D. All right. All right, hopefully you have that. Now we're going to talk about the layers of the epidermis. Okay. First layer, the stratum basal. Okay. This is the base layer where everything comes from. Just one single layer is able to divide and push new layers up. This is where the melanin is. Okay. Yeah, so for the person that wasn't here on Sunday, maybe, yeah, take a screenshot because they went over this. Mindy went over this, I assume. All right. Everybody good with that? Yes. The next layer. What's the next layer? Anybody? Have your notes out from Sunday? You remember? Good. Up. Stratum spinosum. Okay, so we're not dividing them anymore. They still might be alive kind of coming up, but they're more thorn-like. All right, 8 to 10 layers of the spinosum. Wrong way. Oh, yeah. Okay, so yeah, some of you are making comments like, oh, good that we're reviewing this, right? All right, what's the next layer? Okay, you guys were ready to answer that. Look at how fast you got it. There's like 10 people that just, boom, done. All right, so now you can see where you have a nice uniform layer for stratum basal, and then moving up, not quite, I mean, it's still pretty uniform, but it's a little bit more jumbled coming up. The next one, oh, we're getting messy here, all right? We're basically looking like sands of grain, okay? This is the waterproofing layer though, all right? Lipid-rich secretion to fill the space. Granulosum. Yes. Oh, did you misspell it originally? Okay. Good job. Got that? All right. Now, maybe a little bit of a curve. Oh, somebody I think already answered, but what's the next layer? So yeah, I'm getting two answers here. Two answers. Okay. Depending on where you're talking about. If you're talking about the hand, right here, where is the next layer of skin on the hand? Let's put it that way. For the people that answered corneum. Right? Hopefully that makes sense what I'm saying. Okay. Yeah. So just for the palms of the hands and the soles of the feet, we have stratum lucidum. I've more than once, I'm sure I've tripped and fell and brought my hands down and scraped my hands, and am so thankful for that extra layer of skin, because it didn't go past that epidermis. All right. Yeah. All right. And then now, a lot of people already answered. The next layer would be the stratum corneum. Okay. This is the layer that we see. This is the layer that, now you see that layer. Okay. Protective layer from bacteria, virus, chemicals. All right. This is the layer that kind of sloughs off, right? "25 to 50 layers." I'll never forget, we did a class, Denise taught it actually, for geriatric patients. And we went to a facility that had geriatric patients, and we went every week. So we did like soap notes and tried to work on the same people as long as it was there. Joanna, this is, yes, 4 or 5, depending. It's 4 because I didn't really count lucidum, because it's not. It would be 5 if it was the palms of the hands or soles of the feet. Otherwise, it's 4. Okay, I didn't really count lucidum. Anyway, so I went, and the first person I worked on, I was going to do, I had just taken reflexology, so I was going to work on her feet, and took off her feet, her shoes and socks, and there was just this like big puff. There was so much dead skin cells on her feet. It was amazing, amazing. All right, how much? Okay, so Warren was confused. Yeah, no, okay, just to show you, I didn't have it numbered. Didn't have stratum lucidum numbered at all. All right, it was 3 for granulosum, no number, and then 4 for corneum. Okay, somebody was, yeah. I mean, it doesn't have to be numbered anyway, but lucidum is in there as a bonus. Like it's the only. Anyway, that was my story about dead skin cells. It was very interesting, and it was really healthy to work on her feet, just to kind of get all that extra skin cells off. Just put on a lot of lotion for it, right? As well as, as well as, benefits from the reflexology for wherever she had issues. All right. So that is the epidermis. Now let's talk about the dermis. All right, what are structures found in the dermis that are not found in the epidermis? Go ahead and list some things that are in the dermis that are not in the epidermis. Good, Jaden, that's one thing. Yes. All right, so I'm going to start listing them, and let's see if we can get a bunch. All right, so the first thing was nerves. Okay, we've got lymph. Yes, definitely. Blood vessels. All right. Papillary and reticular region. Okay. Yeah, I don't know. I think that would be in the subcutaneous. Hair shaft and follicle, definitely. Veins and arteries, so blood, yeah, blood vessels. Fibroblast, yeah, connective tissue, definitely. All right. What else? What about glands? What type of glands are we looking? Oh, just as I say that, somebody wrote glands. Good job. Oh, there was glands. Naomi said glands too. Well, yep. Sweat glands, sebaceous and sudoriferous glands. Good. Nice. All right. Hair shaft. Oh, there it is. Erectrophilia. That's the last thing. Very good, Natalie. All right. So I think this list is, I think everybody listed, well, as you guys were listing it out, I was calling out everything here. Oh, geez. All right. Good job. Give me 1 second. All right. I'm going to have to move a little bit closer. Okay, good. Everybody got that? Do you need anything? So, another special note after that big long list. All right. I'm going to just list a few. The following is part of the epidermis. Okay, melanocytes, keratinocytes, and Langerhans cells. All right. So hopefully you've got that special note. No problem. Let me know when you got it. Somebody's asking for a little more time. Okay. Good. Nice. Okay, yeah. Just make so. Okay, this is a special note. All right. There are 3 things that are part of the epidermis listed. So, being that the midterm is multiple choice, you're going to have 4 choices. So, if you know that these 3 things are on there, there's going to be something that isn't listed that you know isn't part of the epidermis. Okay. Kind of get the idea where I'm going with that, hopefully. All right. Good deal. Next question. What layer of epidermis do skin cells come from? So we just went over this. Hopefully you know. All right, Alexandra, good. First off the bat, getting it. Okay. I want to see a bunch of people answer. Okay, just a few are answering. So come on, you know this answer. You know this. Well, not quite, Isaac. All right. Well, it's good that we're going over it apparently because most of you have it, which is good. We're looking at stratum basal. So if you didn't answer that, make sure. Oh, germinating layer. So yeah, okay. Somebody answered corneum, stratum basal. All right. Good. All right. Next question. What are the cells that make up new collagen and elastin fibers? What's the name of the cell? Boom, Alexandra, got it. Nice job, Natalie. Eric. And that's okay. Somebody just says it takes a while for them to learn, and yes, I do know you, but that's okay. That's why we're reviewing this, right? So hopefully it sinks in. Good job. Okay, so a bunch of you answered, and you got it. Fibroblast. We're looking for cells that make new collagen fibers, fibroblast. You answered, and then I showed it. Nice. All right, very good. Okay, so now we're talking about having an injury, you're fixing the skin. What are two cells that move into the injury area? Good, that's one, June and Natalie. Okay, good. So the two things that come into the injury area are fibroblasts, make new collagen elastin fibers, okay, knitting back the skin, and then lymph, basically to clean the area. Good. All right. Okay, next question. cells from stratum what? Divide and multiply and are slowly pushed to the surface. And that, we've already gone over this a couple of times, so hopefully, yeah, you have it. All right, somebody answers with an exclamation point. Boom, drop the mic. Okay, it is stratum basal. Divide and multiply, slowly push to the surface from that first layer. Okay, another special note. Been a while. Ready? Mitosis, which means division of epithelial cells, occur in the stratum basal. Oh, this is the last slide before we go to the poll questions. Hopefully, you guys are ready for the poll questions. Oh, I should realize. All right, ready for first poll question? Remember, click on the letter that you think, or just get. All right, here we go. First question. Epidermis cells are produced in the deepest layer of epidermis. What is the process in which they move the superficial layer? And the answers are keratinization, migration, keratinization, or melaninization. So I see people are answering in the question panel, but try and click on the button that you think is going to answer it, right? If you can't click, let me know in the question panel and answer in the question. Yeah, I know. We go from answering in the question panel to clicking on it. It's a little bit different. Okay, I'm 50 seconds in at 68. So go ahead and guess if you don't know, or answer, find an educated guess. A minute in, here we go, 84%. That's okay. 5, 4, 3, 2, 1. Here, close the poll. And we have 72% said keratinization. So if you add that to 6% with the spelling, I guess you got most of it. Okay. So yes, it is keratinization C. You guys are on it. Very good. All right. Next. So somebody said their click won't take. I know that people have said in the past, if you're at full screen, it won't allow you to click on it. So you have to reduce the window, I guess. Can I see again, please? This? Is that what you're looking for? Because this is the answer right here. Somebody asked to see it again. Tiffany. Is that, I'm not sure what you're asking to see again. That question, the question is above it, and then it shows the answers. So that question, take a screenshot of this before I move on. Okay. Yeah, so the question is it's the same slide, this one just shows the answer. Okay, next question. Which is the most superficial layer of skin? And the answers are hypodermis, epidermis, dermis, or exodermis. What is the most superficial layer of skin? How we doing? Half minute in. Okay, now see we're up to 92%. Now I feel so much better. All right, so finish up if you haven't already. I'm going to close the poll in 5 seconds. 4, 3, 2, 1. Nobody else answered, so we'll give this to me. All right, and 79%, pretty good. Remember, epidermis is the most superficial layer of skin, and notice that it's highlighted here. Just a reminder, I won't say it every time, but when it's highlighted, it is a special note when it's highlighted in yellow, okay? So this is a special note. Know that the most superficial layer of skin is the epidermis. All right. Excuse me. Hopefully everybody has that. Tell me if you don't, and I'm going to move on. Next question. What is the function of the integumentary system? And launch the poll. Is it assist in metabolism of carbohydrates, assist in strong sweat, assist in maintaining posture, or assist in controlling body temperature? So I'm not saying that this is the only function of the integumentary system, but it's the one that is the best answer of the choices you have. Put it that way. All right, how are we doing? 86%. Let's go ahead and finish up. Get up to that 92%. So answer the question. If you haven't already, 3, 2, 1, and we're looking at 94%. That's pretty good. 94% of the 89% of the people that answered. I don't know. You do the math of how many people got it right. All right. Closing the or hiding the results. And the answer, yes. And it is a special note. The function of the integumentary system is assisting in controlling body temperature. All right. So you're taking note. Next question. The integumentary system consists of which of the following components? Here we go. Launching the poll. Skeleton, fascia, articular cartilage, and periosteum. Epidermis, dermis, sebaceous glands, and nails. Nailed it. Myofilaments, paramecium, tendons, and dendrites, axons, and synapses. I'm glad you got my joke too. All right, most of you, go ahead and finish up if you haven't. Closing the poll, 3, 2, 1, and 97%. Oh, so close, almost 100%. Very good. Hiding the result, and yes, it is B and special note. Okay, I'm not going to say special note. You guys know it's special note, right? When it's highlighted in yellow. All right, hopefully you have that down. Let's go to the next one. The tissue on the palms of the hands and soles of the feet is thicker because we went over this. The hypodermis is thicker, the dermis is thicker. We walk on both, or the epidermis is thicker. All right. Go ahead and finish up. 78% voted. Last 3 seconds. One person, there you go. All right. So this one, not such a overwhelming answer. Okay. The hypodermis 13, dermis 22. We walk on both. I'm not sure why somebody picked that one. But the answer, is the epidermis is thicker. Know that stratum lucidum is for the palms and the soles of the feet to give you extra protection because you need it sometimes, all right? But it's in the epidermal layer if that happens. Okay? Okay. We're good. I'm going to move on. Like I say, let me know if you need more time or you need to go back. Other than that, I'm going to move on. What does cutaneous mean? Does it mean muscle, skin, nerve, or fascia? Okay, I feel good about this one. What does cutaneous mean? All right, 78%. Let's go ahead and finish up. Oh man. Okay. Closing the poll. And sharing the results, I thought it would be much, much bigger. Skin is 68%. Still not terrible, but Yeah. So we haven't talked about muscles yet. Nerve, fascia is the lesson that's coming up with connective tissue, right? So yeah, skin is the one that we're really focusing on. Yeah, it's okay, but that's okay. So yeah, cutaneous means skin. Okay, it's not a special one. It's okay. We'll pretend like that one didn't happen. All right, let's go to the next question. What is the function of epithelial tissue? Is it absorption, secretion, all of the options, or protection? This is a good example of reading all of the answers before you answer the one you want. You should do that anyway, but okay. How are we doing? 84%. So let's finish up. If you haven't already, I know I can get one or two more people answering. All right, closing the poll. So that 3/4, so everybody got the correct answer here because absorption, secretion, and protection are all functions of epithelial tissue. But if you look, all of the options are correct. So yes, all of the options. So what I want to share with you here is sometimes all of the options is the correct answer, might be the correct answer, not necessarily all the time, but might be the correct answer for the midterm and final. It will never be none of the options. And that's a choice sometimes, but don't pick none of the options because we want you to pick the positive thing, not the negative thing. That makes sense. Anyway, little midterm final pointer. Okay. Sometimes it's all of the options. It's never none of the options. Okay. Hopefully you've got your special notes down there, and we'll move on. Let's see, how many more we got for instruction? 1, 2, 3, 4, 5 more questions. Okay, good. Next question. What are the glands in the skin involved in sweating to cool the body? We went over this a few different ways. Is it sebaceous glands, sudoriferous glands, apocrine glands, or ceruminous glands? Sweat. What glands involve sweating to cool the body? All right, finishing up, last couple of seconds. And closing the poll. All right, 82%, we're back on track. So here I'm gonna hide the results and know that, you know, it's easy to mix up sebaceous and sudoriferous. Just, yeah, try and remember, okay? Sudoriferous gland. make some special notes for that. All right. Give you just a little bit of time to do that. Here we go. Right. Next question. Melanocytes produce melanin in order to help induce deep sleep, protect skin from harmful radiation, help produce vitamins, or help in immune response. Right. Yeah, that one is kind of fun to put that in there. All right. I love that, Joanna. I remember the question because Spanish is sudor, aka sweat. Yep, there you go. I wish I knew Spanish better. All right, I'm closing the poll, and most people got protect skin. Somebody said help induce sleep. Okay, that's not melanocytes or melanin. Okay, melatonin, but yeah. Help produce vitamins, help immune response. No. All right. Oh, I'm sorry. The answer is protect skin from harmful radiation. All right, next question. What is the correct order of layers of the skin from deep to superficial? Okay, so remember, starting at the deepest part, going to the most superficial part. Excuse me. And see. Oh, we're getting there, finishing up. I'm going to close the poll. And what is the results? 2/3 of you said superficial fascia, dermis, and epidermis. And that would be the correct answer. Know that superficial fascia, and then dermis, and then epidermis. All right. Yeah, I would say hypodermis. See, but hypodermis isn't listed here. The superficial fascia would be kind of within the hypodermis. All right. Okay. Hopefully we have that. Yeah, and we're going to be talking about superficial fascia, much more with connective tissue day anyway. So, all right. And next question. What happens during the initial phase of acute inflammation of fibrous tissue? Is it vasodilation, pus isthmus, collagen production, or fibroblast form scar tissue? Let's see, we're at 59%. Interesting. Go ahead and finish up. If you haven't already, take a guess. If you don't know, it's okay. Yeah, I did have Alexandra. Sorry, it's all done. Hopefully. Okay. Anyway. Okay. I apologize. That took way longer than it should have. I was reading the question. Vasodilation by 50%. Oh, half of you. So know that yes, vasodilation is in the initial phase. So we're getting blood coming in. All right. Definitely write that one down. One more question, and then we'll take a break. Okay, everybody got that? Let's go ahead and go to the next question. Last review question of the night. Why is healthy skin so important to the immune function? Is it skin is a protective barrier? The temperature of the skin immobilizes bacteria. Skin is smooth or healthy in hands? That was a clue not to choose D. Most of you are doing a great job in answering. Yeah, vasodilation is basically getting blood to the injury site, I guess. Vasodilation. All right, 86%. I'm going to close the poll, and we're looking at 88%. Not bad, pretty good. All right, and that is the correct answer. Skin is a protective barrier. All right. I wouldn't say the temperature of skin immobilizes bacteria. Skin, yeah, that's a function of you know, helping get rid of the bacteria, but not the temperature of the skin. Anyway, skin is a protective barrier. It's the correct answer. All right. So that is it for the review once again. Let's see, it's 9:10. Let's go ahead and go to 9. I'll give you 15 minutes, 9:25 to go on break. Right at 9:25. And then we'll do a nice little structure review. All right, everybody, we're back. Some of us are back anyway. Hopefully most of us back. And we are going to go to, let's get my tools right here, the structure review. Right. These are poll questions also. Hopefully, just do the best you can with them. Hopefully they make sense. Flexion of the knee and plantar flexion of the ankle are both actions of which muscle? Some people were not listening to me when I told you that it will never be none of the options. The answer is that. Okay. Yeah. Do not answer none of the options. All right. Finishing up. I'm going to close the poll. Take a guess. If you don't know, it's okay. We're here to learn, right? So 2/3 of you said gastrocnemius and hiding the results. Gastrocnemius is correct. Flexion of the knee and plantar flexion of the ankle. So it's crossing the knee joint to make flexion of the knee and coming down to calcaneus to plantar flex the ankle, gastrocnemius. The hamstrings do flexion of the knee, but they don't do plantar flexion. Soleus does plantar flexion, but it doesn't do flexion of the knee. Hopefully that makes sense. No, you're good, Natalie. It's fine. All right. Next question. Which of the following extends the femur? Here we go. Gluteus maximus, soleus, none of the options, or peroneus. Say what again? Oh, I will. I'll go back to it and review it again with you and just go over it. So, which of the following extends the femur? And how are we doing? So let's go ahead and finish up. Take a guess if you don't know. Think about where these muscles are and what they would do as you do. So last couple of seconds and closing. Almost 2/3 said gluteus maximus, which is the correct answer. And extends forward, extends backwards. So rather than thinking about forward or backward, think about opening or closing the joint. So if this is extension, if I close that joint, that's flexion. Okay, if I open it up, it's extension. That's really a bad example with the wrist, but that's all I could do with the camera ankle. Sorry. Anyway, gluteus maximus extends the femur. Okay. I'm going to go back one. Somebody asked me to explain soleus. Oh, I'm sorry. That I went forward and gave you the answer. So we'll just pretend like we didn't see that. Right. So soleus, remember, connects to the distal leg. It doesn't cross the knee joint, so it wouldn't be flexion of the knee. All right. So much for trying to do good. Hopefully that answers your question. All right. Anyway, that's gonna. Okay. What muscles flex the knee? So if you were paying attention, you would already have the answer here. Is it gastrocnemius, soleus, hamstrings, or both gastrocnemius and hamstrings? All right. Good. Most of you have answered. I'm going to go ahead and close the poll in 5 seconds and talk about it. All right. So most of you said A and C, gastrocnemius and hamstrings, which would be the correct answer. So both of those, let me scroll down. Both of them flex the knee because they're crossing the knee joint, and that's the action. Oh, sorry, it should be there. So gastrocnemius flexes the knee, hamstrings flex the knee, but in this case, both of them do. Soleus doesn't because it doesn't cross the knee joint once again. Okay, hopefully that's pretty clear now. What's the next question? Which of these muscles does not insert on the greater trochanter? So think about each one. Which one does not insert onto the greater trochanter? Huh. Okay. Well, it started out 100% wrong, but that's okay. Wow, I'm getting mixed reviews here. Let's go ahead and finish up. Close the poll. And here we go. Wow, I am very surprised. So piriformis came out ahead. And guess where piriformis goes to? That's right. It goes to the greater trochanter. It's gluteus maximus. It does not come out to the greater trochanter. Okay? Close to it, but not quite. Piriformis, gluteus medius, gluteus minimus all come to the greater trochanter. So know that. Okay? Interesting. What's next? Hopefully you guys are, this is helping you. Anyway, different way to look at it. Yeah, good. What muscle is attached to the epicondyles of the posterior femur? We went over this before. Is it soleus, biceps femoris, gastrocnemius, or rectus femoris? Rectus femoris we haven't gone over yet, so I wouldn't answer that. Coming to the epicondyle, not on the condyles, but just above the condyle. And half of you voted. That's Go ahead, bring that percentage up and answer if you haven't already. Interesting. Quite the mix. I told you not to answer rectus femoris, and which is good that you didn't. I'm closing the poll, and look at that. It's mixed. Okay. So thinking about it, and I went over this before, so I'm a little confused. Okay. So here, remember the muscles attached to the epicondyles of the posterior femur. That's right here. Remember that condyles are these bumps. Epicondyles are just above them. That is gastrocnemius. Hopefully does that make it clearer when you see this picture of coming up here to the posterior epicondyle of the femur. Okay, good. Next. Thank you. Okay, next question. Which muscle abducts the femur at the hip joint? So out of these four muscles, which one abducts the femur? Is it gluteus maximus, tensor fascia latae, quadratus femoris, or rectus abdominis? We haven't gone over rectus abdominis, I don't think. Quadratus femoris, no. So which one is it out of, yeah, process of elimination? This is kind of a one that you learn in circulatory also. So I'm going to close the poll in 3 seconds. 3, 2, 1, 83%. Shoot. But most of you got it. 3/4 of you. Good job. Tensor fascia latae is correct. And that is the correct answer. It assists in abduction of the femur. Okay, bringing it out. Gluteus maximus does not. All right. Where does the piriformis muscle originate and insert? Is it the anterior tibia, the first cuneiform, and then the first metatarsal? Is it the iliac crest to the lumbar vertebrae, the pubis to the femur, or is it anterior to the trochanter femur? Excuse me. How we doing? Oh, good. All right. A little bit over halfway there. Five seconds left. Go ahead and answer. If you haven't, take a stab at it. Best guess. Educated guess. And here we go. Good. 80, almost over 3/4 of you, let's say. Anterior sacrum, greater trochanter of the femur. And so I threw in this little picture to show, so you can see greater trochanter is the piriformis coming, and it's kind of shaded here to come to the anterior sacrum, right? And last but not least, what are the two primary actions of biceps femoris? Flexing of the knee and extending of the hip, flexing of the hip and extension of the knee, or extending the knee, flexing elbow and supinating the hand, or extending elbow and pronating the hand. Yeah, educated guess. That's exactly what I said. Okay, so biceps femoris, I go to the hand, all right? Hopefully you don't answer anything going to the elbow or the hand. Biceps femoris. That eliminates 2 of the answers. That being said, before I said that, somebody chose it. So, okay, go ahead. I'm going to close the poll. And 2/3 said flexing knee and extending hip femur, which is the correct answer. Okay, extending the hip and flexion of the knee. All right. Oh, because I'm sorry. It is after 9 o'clock, so that's my rule. I try and wait till after 9 o'clock. Okay, that is it for the. So usually after every review, I'll try and have a structure review of what we've gone over already in that day. So just kind of cements things a little bit better for you. It's 9:41 right now. Did Mindy show you any videos for a crash course? You guys know what that is? No. So I'm gonna show you a video of a review for the skin. This guy is, to me, he's entertaining. He talks really, really fast, but I don't know if some people do. Yeah, John Green, I guess. That's what Natalie said his name is. I didn't know his name. Anyway, yeah, like I say, they were well done. So, or his brother. Sure. Okay. I don't know what his name is. Anyway, I'm gonna play. There's 2 of them. We'll probably only have time for one. We'll see. Anyway, here's the first one. Hopefully your video shows, because like I say, it's kind of entertaining.
When you hear about your organs, you probably think of your heart or your liver or your lungs. Maybe you picture Captain Nemo playing the organ aboard the Nautilus. Why do they have an organ on a submarine? Doesn't make any sense. But your first associations with that term probably overlook your biggest organ. I'm talking about your skin. The glorious, fleshy shroud that keeps the world out and you in. Your skin protects your body against infection and extreme temperatures, maintains your balance of fluids, and even synthesizes vitamin D for your own personal use. Its many nerve endings allow you to sense the outside world, and its sweat glands and blood vessels help you maintain a proper temperature and communicate a whole range of stuff from your health to your emotions through things like blushing and flushing and sweating. It also accounts for about 3 to 5 kilograms of your body weight, and if you could spread it out, it would measure up to 2 square meters, enough to cover your bed. The most disgusting, paper towel thin, waterproof, insulating, stretchy, self-repairing, lifetime-lasting quilt on the planet. It comes in lots of different colors. You can cover it up or show it off or tattoo the periodic table on it if you want. And of course, without it, you would basically shrivel up and die in no time. Together with your hair, nails, and sweat and oil glands, your skin forms your integumentary system. And if you've ever been burned or had surgery or stepped on a nail, you know how fast complications arise when it gets damaged. But it also heals up quite quickly. Layers. Like an everlasting gobstopper, the key to your integumentary system is layers. And although you can't tell by looking at it, your skin actually has 3 of them, each with particular types of cells that have their own skin jobs, to borrow a phrase from Blade Runner or BSG, whichever you like. The epidermis is the only layer you can actually see, assuming that your skin is intact, which is why it's what you think of when you think of skin. It's made of stratified squamous epithelial tissue. But the dermis just below it is where most of the work that skin does gets done, like sweating and circulating blood and feeling everything everywhere all the time. And at the bottom, there's the subcutis, or hypodermis, composed mostly of adipose or fatty tissue. Each of these layers owes its properties and its ability to do its skin job to its unique combination of cells. The bulk of your epidermis, for example, is made up of cells called keratinocytes, which are the building blocks of that tough, fibrous protein keratin that gives structure, durability, and waterproofing to your hair, nails, and outer skin. These cells are constantly dying and being replaced. You lose millions of them every day, enough to completely replace your epidermis every 4 to 6 weeks. That's why if you want to tell the world you love your mom or commemorate your favorite famous physiologist with a tattoo, you gotta make sure the ink gets below the epidermis. If there's a cell in the human body that's been responsible for causing the most pride and the most prejudice in human history, it's another epidermal cell, the melanocyte, the spider-shaped cell that synthesizes melanin, the pigment that gives skin its color. I'll spend more time talking later about why skin color differs around the world, but one thing to keep in mind is that both the very palest and the very darkest human skins on the planet have about the same number of melanocytes. Your particular color isn't about the number of these cells that you have, but instead about the breadth of their spidery cellular extensions, which in turn affect the amount of melanin that they contain. But on a cellular level, we're all the same. Now, your skin, obviously, is also your first line of defense when it comes to protecting you from the outside world, so it may not come as a surprise that you have lots of immune system cells in your epidermis as well. These are your dendritic or Langerhans cells, which are kind of star-shaped, and like white blood cells and platelets, they actually originate in your bone marrow. Once they migrate to the epidermis, their long, skinny tendrils run around the keratinocytes and spend much of their time ingesting the unwanted invaders that are trying to sneak around your skin. Finally, rounding out the quartet of epidermal cells, your tactile or Merkel cells occur deep down at the boundary between the epidermis and the dermis, where they combine with nerve endings to create a sensory receptor for touch. What's a little weird though is that all of these cells are organized differently in the skin that covers your body. In fact, in some places you have more layers of epidermis than others. Your thick skin, and yes, that's what it's really called, is the tougher stuff on the palms of your hands and the soles of your feet, and it consists of 5 epidermal layers. Your thin skin covers everything else with just 4. To get to know what's going on with your thick skin, let's just imagine you're walking around barefoot in the yard and suddenly you feel a shooting pain. You've just stepped on a big old nail and it's penetrated all of the layers of your epidermis. First, it pierced your stratum corneum, which means, pardon my Latin, horny layer. This is the outermost layer and also the roughest, made up of about 20 or 30 sheets of dead keratinocyte cells. This is the layer that you're always sloughing off and feeding to dust mites, but while it's in place, it offers basic protection from environmental threats. From there, the nail drives through your stratum lucidum, or clear layer. This holds 2 or 3 rows of clear, flat, dead keratinocytes that are only found in the thick skin of your palms and foot soles. So in places where you only have thin skin, this layer is what's missing. Things start to get more serious in the granular layer, or stratum granulosum, because this contains living keratinocytes that are forming keratin like crazy. This layer looks kinda grainy because those cells are getting compressed and flattened as they move up through the epidermal layers, maturing as they go. The deeper you go through the layers of the epidermis, the younger the cells get. Regeneration happens in the lower layers, and new cells move up toward the surface, maturing along the way, where they eventually die and slough off from the surface of your skin. This whole process is due in part to the fact that the epidermis is epithelial, so it's avascular. That means that all the oxygen and nutrients that its cells need have to come from the dermis below it. So as epidermal cells mature and get bumped up by younger cells forming below them, they move further and further from the blood supply and end up essentially suffocating. When that nail cuts through the 4th layer, the stratum spinosum, or spiny layer, it's getting closer to the point where cell regeneration, or mitosis, is active. These cells look prickly when they're dehydrated from microscope slide preparation, hence the name, and that's because they contain filaments that help them hold to each other. And finally, that dang nail touches down on your deepest, thinnest epidermal level, the basal layer, or stratum basale. It's just a single layer of columnar cells, but it's like a cell factory where most of that new cell production happens. This stratum is also what connects the epidermis to the layer of skin below it, the dermis. Feeling a little overwhelmed by all the layers? Just remember, come, let's get sunburned. It's a mnemonic. I mean, though, who came up with that? Because if you own some skin, you know you don't want to get sunburned. The ultraviolet radiation in the sun can damage the epidermis, causing elastic fibers to clump up, leading to that telltale leatherface condition. Plus, getting sunburned temporarily depresses your immune system, because remember, you have immune cells in your epidermis too, and the radiation can actually alter your skin cells' DNA, leading to skin cancer. We're gonna go into your skin's love-hate relationship with sunlight more next week, but in the meantime, seriously, wear your sunscreen. skin. Now, skin damage of any kind can get serious when it affects the dermis because it's not only got loads of those collagen and elastin fibers which help make your skin strong and elastic, it's also full of capillaries and blood vessels. And it houses the nerve fibers that register sensations like temperature, pressure, and pain, as well as parts of your hair follicles and oil and sweat glands with the ducts that lead up to the surface of the skin. So the dermis is where most of the skin's work is done, and it does it in just 3 layers. The upper papillary layer is composed of a thin sheet of areolar connective tissue that's riddled with little peg-like projections called dermal papillae. These papillae are pretty neat because in the thick skin of your hands and feet, these tiny protrusions form unique friction ridges that press up through the epidermis to help our fingers and feet grip surfaces. Your fingerprints. Just below that papillary layer is the deeper, thicker reticular layer that makes up 80% of your dermis, made up of dense, irregular connective tissue. All of the dynamic parts contained within the dermis, like the nerve fibers and capillaries, are distributed between both its layers. So anytime you get cut enough to bleed or feel pain, you know that you've broken through the epidermis and lacerated the dermis, which, by the way, is the layer that tattoo needles have to reach in order to work. It's the only way to make tattoos permanent, but also it means getting tattoos hurts and bleeds. Finally, something of a footnote to your skin is its third and most basal layer, the subcutis or hypodermis. It consists of mostly adipose connective tissue, basically a seam of fat, and it provides insulation, energy storage, shock absorption, and helps anchor the skin. In short, your hypodermis is where most of your body fat hangs out. But there are more skin things to discuss, so in our next lesson we will tackle big questions like, does lotion really do anything? How does deodorant work? And what will make my hair soft and shiny and irresistible? For now, though, you learned all about skin, the main organ of your integumentary system. We looked at the structure, mechanism, and function of your 3 layers of skin, the epidermis, dermis, and hypodermis, and their various sublayers. We talked about the roles of melanin and keratin cells, what happens when you step on a nail, how to ensure you get a good tattoo, and why it pays to wear sunscreen. Thank you for watching, especially to all of our Subbable subscribers who make Crash Course possible for themselves and for the world. To find out how you can become a supporter, just go to Subbable.com. This episode was written by Kathleen Yale, edited by Blake DiPastino, and our consultant is Dr. Brandon Jackson. Our director and editor is Nicholas Jenkins, the script supervisor and sound designer is Michael Aranda, and the graphics team is Todd.
All right, enough of that. All right, everybody, I think it's close enough to 10 o'clock. I left this little sign up there. Thank you so much. Have a great night and rest of the week. Like I say, don't forget your homework, please. Everybody turns it in. All right? Time. Thanks so much. Have a good night. Good night, David. Okay. Okay, I've got 4 people still signed in. Up 3 people. Good. Alexis, Erica, Jade, please sign out. Have a good night.